Subtraction using partial differences. Partial differences relies on kids understanding place value as well as having the luxury of negative numbers. When we teach subtraction, we need to be thinking about, yes, we're taking away, but we're also finding the difference, or we're finding a distance between numbers. If we don't allow kids to have those different flexibilities of thought, then when we do the standard algorithm, we're not sure why we borrow or when we borrow. So using partial difference, we are asking them to think about values of numbers and how much is left and how much they've used. So for 75 minus 32, you want to start in the tens place. 70 minus 30 would leave me 40 things. I have 5 things and I took away 2 of them, so that leaves me with 3 things. We're going to add these together because what we have already done is we've looked at each of our place values and we've made adjustments to those place values by subtracting what we needed. So 40 plus 3 is 43. This is an easy problem in subtraction in that we didn't have to borrow. So what happens when you do have to borrow? Same idea as over here, is that you start in your largest place value and you say 200 units minus 0 units leaves me still with 200 units. 0 groups of 10 minus 6 groups of 10. I don't have enough groups of 10 to subtract all of those. So I still will owe 6 groups of 10, or 60. I have 4 units of 1. I will need to subtract 9 units of 1. Well, because my bottom number, or the number that I need to take away, is larger than my top number, or the number I have, I will need to still owe some, or I will need to still find some to take away. So 4 minus 9 is actually negative 5. So then you have the kids step through each of these. 200 minus 60 is 140, minus 5 more is 135. Now, you can have the kids hold those numbers off to the side if you think that it's easier. So if you think 200 minus 60 is 140, and then 140 minus 5 is the 135. If your kids need to, if they can't hold the 140 in their head, have them write it down so that then they are thinking just this last problem. Partial difference, if you have numbers that you have to borrow in one case but not in another. So again, I have 200 things. If I have 70 things and I subtract 60 of them, I have 10 left over. But then I have 4 things minus 9 things, which means I still owe 5. So this first step I need to add and then I need to subtract. So 200 plus 10 is 210. Minus 5 is 205. If I were to have the kids think about this, as a whole group of 3, it would be very challenging. They need to step it in sections. They could do what is 10 minus 5, which is 5, so then 200 plus 5, or they can just walk down the problem. In any case, all of this is adding, so 200 plus a positive 10 plus a negative 5. This step always is addition, no matter what you are doing. The partial difference, in comparison to the standard algorithm, the borrowing happens at the bottom, but it's more of just a subtraction, a mental computation of what is this number minus this number. And it's a smaller value and we're not over borrowing, crossing off, and figuring out what we're using. However, if the kids see this, they can start to understand, oh, I'm going to need to break up my 200 so that I can get rid of that 60. And they'll start to understand why they will need to go over and do the borrowing and moving it back in the standard algorithm.